Principle. Emission spectroscopy involves the analysis of radiation emitted by atoms or ions when they are thermally excited. The salts of the metal solution are introduced into a hot flame. The flame is produced by the fuel and oxidant mixtures fed into the burner. The following processes occur when the metal ion solution is nebulized through the flame. The solvent gets vaporized, leaving the particles of salt. The salt is vaporized and dissociated into atoms. Atoms are vaporized and excited. The excited atoms emit radiation characteristic of the flame. The wavelength of radiation, which is characteristic of the atoms of a particular element, is given by the equation. The emitted radiation is characteristic of each element, and its wavelength corresponds to electronic transitions. The intensity of the emitted radiation is proportional to the concentration of the element in the sample. Instrumentation. The main components of a flame emission spectrometer include the burner, nebulizer, optical
burner. The burner produces the flame required to excite atoms. It must vaporize the solvent, dissociate salts, and ensure steady excitation. The flame temperature depends on O. The type and ratio of fuel and oxidant. O. The nature and amount of solvent. O. The burner design and flame zone used. Nebulizer. The nebulizer is a closed chamber connected with the sample through a tube. It also has a continuous supply of fuel and oxidants for the smooth flow of the flame. The nebulizer also contains inert gas which acts as a carrier of the sample molecules toward the flame. Mirrors. A front-surfaced mirror is placed behind the flame to reflect emitted radiation back toward the entrance slit of the monochromator, maximizing light collection. Slits. Entrance and exit slits help in controlling light dispersion and in filtering out interfering wavelengths before detection. Monochromators disperse the emitted light to isolate specific wavelengths. Prisms, typically made of quartz or gratings, are used to perform this dispersion. Filters. Used when only one or a few emission lines need to be isolated. Optical filters allow only the desired wavelength to reach the detector while absorbing others. Detector. A photomultiplier tube detects the intensity of the selected radiation and converts it into an electrical signal for measurement and analysis. Working of flame emission spectrometer. Desolvation. The sample is mixed in the solvent in the sample chamber. So, in this step, the metal particles are dehydrated in the flame, thus evaporating the solvent. Now only metal particle remains in the flame. Vaporization. The metal particles are further dehydrated and they get converted into gaseous particles. That's why this process is known as vaporization. Atomization. In this step, the metal ions or molecules get bifurcated into an individual atom with the application of extreme temperature. Different metals have different atomization temperatures. Some of them require only less temperature, whereas some of them require temperature up to 1000 degrees Celsius. Excitation. In this step, the atoms absorb energy from the flame and get transferred from the lower energy state to the higher energy state. The excitation energy will be different for different metals as different elements have different band gaps. Emission. Finally, when the atoms return to their ground state, they emit the absorbed radiation. The emission radiation has different wavelengths by different elements. This is finally passed. Applications. It is used for the analysis of ferrous and non-ferrous alloys. It is used for the determination of trace metal impurities in alloys, metals, reagents, and solvents. It is used for the analysis of metals in geological, environmental, and biological materials. Water analysis ICP instruments have been coupled with mass spectrometers to provide a powerful analytical technique. Most applications of FES have been the determination of trace metals, especially in liquid samples. It should be remembered that FES offers a simple, inexpensive, and sensitive method for detecting common metals, including the alkali and alkaline earths, as well as several transition. FES detectors for P and S are commercially available for use in gas chromatography. FES has found wide application in agricultural and environmental analysis, industrial analyses of ferrous metals and alloys, as well as glasses and ceramic materials, and clinical analyses of body fluids. Flame emission spectroscopy is useful for the determination of alkali and alkaline earth metals. It is used in the determination of lead in petrol and determination of calcium and magnesium in cement. Flame photometry has been applied to the analysis of a wide variety of materials, including biological fluids, soils, plant materials, cements, glasses, and natural waters. The determination of sodium, potassium, and Ca in such diverse samples as blood serum, urine, soil extractors, and industrial and natural water is standard procedure in many laboratories.